Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating world of concept cells, neurons that seem to represent abstract ideas in our brains. It's mind-blowing stuff, isn't it?
Absolutely. I've been reading about this, and it completely changes how we think about memory and abstraction. So what's the core idea here? How do these concept cells actually work?
Essentially, these cells fire for a specific concept, regardless of how that concept is presented. A picture of Jennifer Aniston? The written name, Jennifer Aniston? A mention of her in a podcast? The same neuron might fire for all of them. It's not about visual details, but about the abstract idea of Jennifer Aniston.
That's incredible. So it's not just about recognizing faces or objects, it's about understanding the concept itself. But wasn't this idea initially ridiculed? I mean, the grandmother cell concept seemed far-fetched.
You're right. The idea of a single neuron representing a complex concept like your grandmother was initially dismissed as inefficient and unrealistic. But then, researchers started finding these highly selective neurons, firing specifically for certain individuals, places, or ideas. The Jennifer Aniston neuron was a breakthrough.
Right, and it wasn't just one neuron, was it? The article mentions millions of cells could be involved in representing a single concept. That makes more sense, doesn't it? A more distributed system.
Exactly. It's not a one-to-one mapping. Millions of neurons contribute to representing a single concept, creating a more robust and flexible system. It's a network, not a single switch.
So these concept cells aren't just about recognition. They're crucial for memory formation, right? The article mentions their role in linking objects to locations, for example.
Precisely. They seem to be central to how we build memories. They're the what in our memories, while place cells provide the where. The interaction between these cell types is key to recalling experiences.
And it's not just long-term memory. The article also mentions their role in working memory, that temporary storage we use for tasks like remembering a phone number.
Yes, concept cells seem to remain active during working memory tasks, helping us hold information in mind for short periods. And interestingly, their activity seems to increase the likelihood that those memories will transition into long-term storage.
This is all incredibly complex, but also incredibly elegant. The idea that these cells can adapt and even take on different roles, like a Swiss Army knife, is fascinating. It suggests a level of plasticity and efficiency we hadn't fully appreciated before.
I agree. The brain's ability to repurpose neurons for different tasks is truly remarkable. It highlights the brain's adaptability and its capacity to optimize its resources. It's a testament to the elegance of biological systems.
So what are the next steps in this research? What are the open questions?
Well, one big challenge is that studying concept cells requires invasive procedures. We can only study them in patients undergoing brain surgery. That limits the research significantly. Also, defining concept itself is tricky. We still don't fully understand what kinds of concepts are represented by these cells.
And the implications are huge, right? Understanding how concept cells work could revolutionize our understanding of intelligence, memory disorders, and even consciousness.
Absolutely. It's a field ripe for discovery. And who knows, maybe someday we'll even understand how we form concept cells for concept cells. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of neuroscience. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the Liskov substitution principle, a cornerstone of solid principles in software design. It's often misunderstood, so let's clear things up.
Absolutely. I've always found LSP a bit tricky. The classic rectangle-square example is often cited, but what's the real core issue there?
Exactly. The problem isn't that a square is a rectangle mathematically, it's about behavioral substitution. If you have a function that modifies a rectangle's width and height independently, that breaks with a square, right? Because changing one automatically changes the other.
Right, you can't treat a square as a fully interchangeable rectangle. So inheritance isn't the solution here?
Precisely. The article champions composition and interfaces instead. Instead of inheriting from rectangle, square and rectangle would both implement a shape interface, each managing its area calculation independently. This avoids the unexpected behavior.
That makes perfect sense. So it's about ensuring that subtypes behave as expected within the context of their base type's contract. No surprises.
Exactly. The article also highlights real-world examples like payment processing. Having different payment processors, credit card, debit card, implement a common payment processor interface allows for flexible checkout services without needing to know the specific implementation details.
That's elegant. But what about common pitfalls? The article mentions unexpected exceptions and returning null where the base type doesn't.
Yeah, those are sneaky. A cached user repository, for instance, shouldn't throw an exception if the cache isn't initialized. It should gracefully return null, just like the base user repository. Similarly, a remote data fetcher should return an empty list if it fails to fetch data, not null, to maintain consistency with the base type's contract.
So how do we ensure LSP compliance? The article suggests contract tests and documenting pre- and post-conditions. That seems crucial.
Absolutely. Contract tests verify that all subtypes meet the base type's contract, and clearly documenting pre- and post-conditions, what the method requires and guarantees, helps prevent unexpected behavior and ensures everyone's on the same page.
I see. It's all about clear contracts and consistent behavior, right? Avoiding those "this behaves differently" comments.
Precisely. The article emphasizes that inheritance isn't a silver bullet. Composition often provides better flexibility and avoids LSP violations. It's about designing for substitutability and predictable behavior. And remember, consistent return types are key, avoiding unexpected nulls or exceptions.
This has been incredibly insightful. Thanks for breaking down LSP so clearly. I feel much more confident tackling it now.
My pleasure. Remember, understanding LSP leads to more robust and maintainable code. Stay tuned for our next episode on the open-closed principle. Thanks for listening to Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the mesmerizing world of Rafael Araujo, an artist who seamlessly blends mathematics and nature in his breathtaking geometrical masterpieces. Get ready to be amazed.
I'm already intrigued. So what's the core concept behind Araujo's work? Is it purely aesthetic or is there a deeper meaning?
It's both, actually. Araujo's art is stunningly beautiful, but it's also a profound exploration of the mathematical principles underlying natural forms. He uses geometry, specifically the golden ratio and spirals, as the foundation for his incredibly detailed drawings of shells, butterflies, and other natural elements. He sees it as a way to worship the Platonic perfection of nature, which is pretty profound, right?
Absolutely. It's fascinating how he manages to combine such precise mathematical structures with the organic, often chaotic beauty of nature. It's not just about drawing, it's about revealing a hidden order.
Exactly. And the amazing thing is, he does it all by hand. No computers, just a lamp, ruler, compass, and protractor. He spends, 100 hours on some pieces. And can you imagine the dedication?
100 hours? That's insane. The precision required must be incredible. No room for error, I'd imagine.
You're right. He says it himself. Errors are paid dearly. He leaves the construction lines visible in his final pieces, highlighting the meticulous process and the underlying mathematical framework. It's a testament to his dedication and skill.
That's a really interesting artistic choice, leaving those construction lines visible. It almost elevates the process itself to a work of art. It's like he's inviting the viewer to participate in understanding the creation. It's not just about the final product, but the journey to get there.
Precisely. And he's not just keeping this to himself. He's created coloring books based on his designs, allowing others to engage with his work and explore their own creativity within his framework. It's a fantastic way to share his passion and philosophy.
That's a brilliant idea. It democratizes the art, making it accessible to a wider audience. It's not just for passive viewing. It's an active engagement with the concepts he explores. It's a beautiful way to share his vision.
Absolutely. And for those who want a deeper dive, he has several coffee table books showcasing his work. It's a truly remarkable body of work, a testament to the power of combining artistic vision with mathematical precision and a deep reverence for nature. It's inspiring, really.
It really is. It's a beautiful example of how art and science can complement and enhance each other, revealing hidden depths in both. Thanks for sharing this. It's been a fascinating discussion.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you enjoyed this exploration of Rafael Araujo's amazing work. Until next time, goodbye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.